Hey everyone, welcome back to my Calculus 1 series. In today's lesson, we'll be going over the product and quotient rule and a few worked examples. So the product rule, we'll start off with that. And basically this is when we have the derivative of the product of two functions. So f of g, there should be f of x times g of x. And it's important to note that this right here is not equal to this right here. So we can't just multiply the two derivatives. These two are not equal. So this is not equal to this. And there is a proof to it. However, I won't be going over to it. The more correct version of this is that we are going to take the derivative of just f itself. So the first one right here. And then we multiply this by just g of x without taking the derivative. And then we add on to it the derivative of g of x, and we multiply that by f of x. So as you can see, first we kind of take the derivative of f of x, and then we don't take the derivative of g of x, but then we take the derivative of g of x, and then we kind of leave f of x alone. So that's the product rule, and essentially it's just a formula. There is like a mathematical proof again to it, but this right here is just important to know because this looks a lot like what we used to do with the sum rule and the difference rule, but it does not apply for the product rule. Now the quotient rule is just like it sounds. If we have the division of two functions, right, this right here will also be a sort of formula. It's not just equal to, we can't just say this about it, over d over dx of g of x. Like this is not equal. These two right here are not equal to each other. So it is another formula, and I will be giving it here. But it's kind of similar to the product rule. So first what we're going to do is we are going to take the derivative of, like we started with f of x. So like kind of the first function, this one right here. And then we're going to multiply it by g of x. Just no derivative, nothing, just the plain function g of x. And instead of adding, now we're going to subtract the derivative of g of x times f of x. And now you can see that the signs have switched here. So before it used to be a plus, now it's a minus. But another part switches, and that's the denominator. But it's pretty easy to remember. You just square the denominator. So yeah, these are the right here and here. These two are the formulas for product rule and quotient rule. It's pretty simple. Like there's not much to it. It's just a formula. You kind of got to remember it. And so yeah, we'll just go over two worked examples of how to apply this. So here is our first example. We're given this function x times e to the x, and we can see that this is a multiplication of these two functions. The the linear y equals x function and the exponential y equals e to the x function. So obviously if we were asked to find the derivative of this, we would apply the product rule, and it would go as such. So we want to take the derivative of first right here f of x, and then this would be g of x in a sense. So let me just label that. This would be f of x, this would be g of x. And we want to take the derivative of f of x first, right? So d over dx of x, and then we just want to multiply it by g of x, which is e to the x. And then we're going to add on the derivative of the second one, which is g of x, so e to the power of x, and we're going to multiply it by x. So we know that the derivative of this linear function right here is just going to be 1. So we're just going to be left with e to the x. And we're going to add on the derivative of e to the x, which is just e to the x, and we're going to keep this times x right here. So now we can just simplify this a bit further. We can factor out e to the x, and we'll be left with 1 plus x. And there you go. There is the derivative of x times e to the x using product rule. Now let's say we are given a function like this, and we are asked to find the derivative of it. Again, we can see that this is a division now of two functions, and so we are going to be using the quotient rule. And so here it goes. So this is f of x, and then this will be g of x in a sense. So we're going to apply the quotient rule right now. So first what we do is we take the derivative of f of x. derivative of x squared plus x minus 2, and we multiply this by g of x, which is x cubed plus 6. And now instead of adding, we're going to subtract the derivative of, now we already took the derivative of f of x here, so we're going to take the derivative of g of x now, so the derivative of x cubed plus 6, and then we are going to multiply this by x squared plus x minus 2, which is f of x in a sense. And the last thing we got to remember is that the denominator is going to be squared. So now we can go on to simplify these functions. The first derivative that we have of x squared, I'm not going to simplify it completely. I'm just going to kind of write out what the derivative is. So first we're going to drop the power and subtract 1, which will be 2x. Then the derivative of x is just 1, and the derivative of minus 2 is 0. So we're left with that. And then we want to multiply it by x cubed plus 6 and subtract away the second derivative, this one right here. And so we're going to drop the power and subtract 1, and then the derivative of 6 is just 0, so we're left with 3x squared. And then we want to multiply this by x squared plus x minus 2. And this is all going to be over x cubed plus 6 squared. Now you can go on to simplify this, but I'm not going to because that's not the purpose of this video. The purpose of this video was to kind of learn how to apply these two formulas. So yeah, essentially this is it. If you want to simplify, go ahead, but I won't be. So yeah, that was basically it for the product rule and the quotient rule. It was a pretty quick video. It was just two formulas and kind of how to apply them. Like usual, if this video has helped you out, please like and comment as to what I helped you out in. And if you're new to the channel, please like, comment, and subscribe. It would be greatly appreciated. And yeah, I'll catch you guys in another one.